Section 7.4, the trigonometric identities. In our book there's, I think, 3 sections about trigonometric identities, but we only cover the first in our curriculum. So this is the last section of Chapter 4 we're going to cover. I want you to recall all the identities that we learned back in Chapter 6. We had the quotient identities, right? That tangent theta is sine over cosine and cotangent is cosine over sine. We have the reciprocal identities. Cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. And the Pythagorean identities. Cosine squared plus sine squared equals 1. Tangent squared plus 1 equals secant squared. Cotangent squared plus 1 equals cosecant squared. And last but not least, the even-odd identities. The sine of negative theta is minus sine of theta. Same for cosecant, tangent, and cotangent. Those are all odd functions. And that cosine and secant are even functions, meaning that cosine of the opposite of theta is the same thing as cosine of theta, and similarly for secant. These need to really be memorized. If you haven't already, you need to work on them. You have to become really comfortable with them so that you can use them all over the place in calculus. This section helps, and it kind of gives you a little glimpse into what kinds of things you'd be expected to be able to do when you're working with functions in calculus. What we're going to do in this section is we're going to do what's called establish identities. What does that mean? Well, let's look at an example, and you'll see. So we're going to establish the identity that sine theta over 1 plus cosine of theta plus 1 plus cosine of theta over sine theta is equal to 2 cosecant theta. So to establish this identity, what we're going to do is we're going to show that one side of this identity, and identity is something that's true for all values of theta, that one side can become the other through algebraic manipulations and by using the identities that we just reviewed. Okay? It's always a good idea to start with the more complicated side. So, I'm going to start with this left-hand side. The left-hand side says sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta. Okay, that's all it says. Now what I'm going to do is I'm going to try to work through it with some algebraic things and some identities to get it to be 2 cosecant theta. Alright? Now when I look at what I've got, I say, that's interesting. I have 2 fractions. Almost all the time if you have 2 fractions, you want to put them together with a common denominator. So my common denominator here is going to be sine theta times 1 plus cosine theta. I need both denominators multiplied together. So I'm going to multiply the first term by sine theta over sine theta, getting a common denominator. The second term I'm going to multiply by 1 plus cosine theta on both the top and the bottom. Okay? So what do I have then? For the first fraction numerator, we have sine squared theta. The second fraction numerator, we have 1 plus cosine theta squared, right? So that entire 1 plus cosine theta is being squared. And our common denominator that's now under both is sine theta plus times 1 plus cosine theta. Alright, now what? Well, looks like I could multiply out this square here, yeah? That might be good. I'm seeing that there's a sine squared theta here, and I know that's part of my Pythagorean identity, one of them. And I think if I can combine it with a cosine squared theta that I can get by multiplying out over here, I'm going to be able to get a 1. And that's always a nice thing, to be able to get 1s anywhere you can. Okay? Alright, so we get sine squared theta plus, now be careful when you multiply this out, remember it's a perfect square trinomial. So it's 1 plus 2 cosine theta plus cosine squared theta. Right? You could also FOIL it if you're not sure of that formula over the same denominator. Ah, look, it worked. Notice what I have here. I have my sine squared theta and my cosine squared theta. Oops, sorry about that. Being added together, because there's a plus here. Oh my goodness. Sorry. Because there's a plus here, right? I have sine squared theta and cosine squared theta equals 1. Alright? Alright, so what do we get next? Well, we'll replace those guys with a 1. So I have 1, plus there's another 1 up there in the numerator, plus 2 cosine theta, all over sine theta times 1 plus cosine theta. I'm going to combine like terms, always a good idea. 2 plus 2 cosine theta over sine theta, 1 plus cosine theta. Notice I'm not multiplying out the denominator, right? Why not? Well, what I'm headed for is 2. Sorry, I was interrupted by my son. So remember what we're looking for, right? 2 cosecant theta right here. It does not have a denominator. So what I'm thinking is if maybe I can do some canceling, that would be good. So I'm going to leave the denominator factored. Often we leave denominators factored when we're working with these, or in all kinds of things. Okay, let's see. In the numerator, I can factor out a 2. I end up with 1 plus cosine theta, and I say, oh yay, it worked. There's a 1 plus cosine theta in the denominator and a 1 plus cosine theta in the numerator. Those are going to cancel. That's 2 over sine theta. Now remember what I'm headed toward? 2 cosecant theta. I know that cosecant theta, right here, right, is 1 over sine. So I can rewrite this as 2 times 1 over sine theta, right, which is 2 times cosecant theta. Done. All right, so I've just established that identity. Sorry, I don't know where we got cut off. This is what I did so far. Factored out 1 plus cosine theta in the top, canceled it with the bottom, replaced 1 over sine theta with cosecant theta, and that's what we were trying to do. All right. So the biggest question that I get when I teach this is, how do I know what to do from one side to the other, to get to the other? Well, there's a few things you can do. Here are some hints, things to try, yeah? Use any identity you can that involves the given trig functions and your goal trig functions. So if you see something that relates the two, it's a good idea to maybe try to use it somehow. Okay. One thing we did in the last one is to combine, but sometimes you also separate fractions with an LCD. Factoring is good. That's one thing we also did in that example. Yeah. A little trick that sometimes works really well is if you put every trig function in terms of sine and cosine. And cosine, especially if you're trying to go from a trig function that doesn't easily change into a different one by reciprocal or something like that. If you put everything in terms of sine and cosine, sometimes you can then manipulate it and turn it into what you want. And then here's another trick that we're going to do in an example in a little bit that gets used quite a bit. Sometimes you have to introduce something new into the problem. So you could multiply by 1 minus sine theta over 1 minus sine theta, or 1 minus cosine theta over 1 minus cosine theta. Notice these are both equal to 1, right? So you're not changing anything when you do it, but you sometimes, if you do it, you can complete one of the Pythagorean identities. To get a 1, right? And a lot of times getting a 1 can be really part of what you want to do. All right, let's do another example. We're going to establish that tangent u minus cotangent u over tangent u plus cotangent u plus 2 cosine squared u is equal to 1. All right. So we're going to start with the more complicated side, which is the left side, clearly. Okay, so we're going to start with this guy, plus cotangent u plus 2 cosine squared u. Okay, we're going to see what we can do with that. Now, I know that I see a cosine squared, I see a 1, I'm thinking maybe a Pythagorean identity might pop up somewhere, right? But before I can get there, I have to deal with this tangent and cotangent stuff, right? Well, if I'm going to try to use a Pythagorean identity, I probably want a sine squared somewhere. I already have cosine there. So I'm thinking if I can get tangent and cotangent in terms of sine and cosine, maybe I can get some things to cancel out or something, and maybe we can get it all to work out. So that's what I'm going to do. All right? So I'm going to take tangent u and write it as sine u over cosine u. Cotangent is cosine u over sine u. That's the numerator of my fraction. Then I have similarly on the bottom sine u over cosine u plus cosine u over sine u. And then of course I still have the plus 2 cosine squared u. Alright, let's keep going with this. Now, on the numerator, I'm going to now do what we did before. We're going to combine the two fractions in the numerator with the same denominator. So I see that the common denominator is cosine u sine u. So sine u over cosine u needs to get multiplied by sine u over sine u to become that LCD. Cosine u over sine u needs to be multiplied by cosine u over cosine u. All right. And then in the denominator, similarly, sine u will have to be multiplied, sine u over cosine u is going to be multiplied by sine u over sine u. And plus is the only difference here, cosine u over sine u times cosine u over cosine u, again plus 2 cosine squared u. Okay. Now, let's put them together. I get sine squared u minus cosine squared u all over cosine u sine u. Now, that denominator is going to be divided, right? So, and it's going to become one fraction. When you divide fractions, you flip and multiply. So I'm going to go ahead and flip it over. So the LCD is on the top, cosine u sine u, and the numerator, which is right here, right there, is going to end up on the bottom because I'm flipping to multiply. So I have sine squared u plus cosine squared u plus 2 cosine squared u. All right. Notice what happens. I get to cancel there, and I know that sine u plus cosine squared u is a 1. Sine squared plus cosine squared is a 1. Aha! So I have sine squared u minus cosine squared u all over 1, don't need that, plus 2 cosine squared u. Right? Well, I have like terms right here. I have sine squared u plus cosine squared u. And what is that? 1. Yay! I'm going to do some more examples in another video. The most important thing is to keep trying things. If you get way off, start over and try something else. You will get better at it.